All right, let's get right into it. Today, we're going to look at one of the most elegant and honestly fascinating events in the entire cosmos, a galactic collision that's just getting started. We're talking about this incredible pair, NGC 4567 and 4568, a system that has the perfect nickname, the Heart Galaxies. And there they are. I mean, just look at that. 60 million light years from us, these two absolutely magnificent spiral galaxies are locked in a gravitational dance that has literally just begun. To our eyes, they almost look peaceful, right? Kind of like two starry islands just brushing past each other in the dark. You know, someone described it perfectly, calling this whole thing a chance encounter perfect for Valentine's Day. And it's a great metaphor for what we're seeing, this cosmic connection that's just starting to form. But like any first encounter, there is way more going on beneath the surface. So that brings us to the big question. Are we just seeing a gentle cosmic hug, a simple overlap in the sky? Or is this the quiet calm before the storm, beginning of a spectacularly violent collision that's going to completely reshape them forever? Well, that's exactly what we're about to find out.
So let's get properly introduced to our cosmic subjects here.
Okay, so both NGC 4567 and 4568 are spiral galaxies, a lot like our own Milky Way, actually. They hang out in a pretty busy neighborhood called the Virgo cluster, about 60 million light years away. And if you were to just look at them, their starry structures seem totally normal, almost completely undisturbed. But that little phrase, for now, well, that's the key to this whole story. To really see what's happening, we've got to go deeper. And this is where science basically turns into a cosmic detective story. So if their stars aren't being flung all over the place, how do we know they're actually colliding? I mean, a regular telescope just isn't going to cut it. To find the hidden evidence, astronomers needed a whole new way of seeing. And that tool is ALMA. The Atacama Large Millimeter/Submillimeter Array is this incredible telescope down in Chile. Now, it doesn't see starlight like you and I do. Instead, it sees the cold, invisible clouds of molecular gas, and that is the raw fuel for making new stars. This is so important because in a galactic collision, it's the gas that crashes together first. And wow, this slide just shows you the difference so clearly. On the left, you've got that beautiful picture of the stars that we can see, but on the right, that's what ALMA sees. It's a map of that invisible gas, and you can see this bridge of material that is physically connecting the two galaxies. That is not a coincidence. The data from ALMA was just undeniable. I mean, if these two were just passing ships in the night, there'd be a clear gap between their gas clouds. But what the research shows is a smooth connection. So, bottom line, this proved a real physical interaction was happening. But ALMA found something even more specific, something even cooler. And this leads us to the biggest discovery of the whole investigation, the absolute smoking gun that proves not just that they're colliding, but exactly how they're doing it. Scientists found something they called a molecular collision front. Think of it like a cosmic shockwave. It's the literal line in space where the gigantic gas clouds from each galaxy are slamming into each other. And what's incredible is that this was the very first time a front like this has been so clearly seen. We're watching the collision happen in real time. And what happens when you smash two giant clouds of gas together? Well, you get a whole lot of compression. This collision front has squeezed all that gas into a massive, stringy structure. And this thing is huge. It stretches for nearly 6,000 light years. Now get this. Inside that long filament, ALMA found 4 enormous, super dense clouds of gas. Each one of these cosmic clumps contains about 1,000,000 times the mass of our sun. That's just a staggering amount of raw star-building material. And these clouds are so massive, their own gravity is holding them together. They are, for all intents and purposes, the seeds, the direct precursors of what are going to become superstar clusters. Just imagine these dazzling collections of thousands, maybe even millions of bright young stars. But here's where the story gets even weirder. We have this massive collision front, but the galaxies themselves, they still look pretty normal. And that's because it turns out not all galactic collisions are the same kind of spectacular cosmic car crash. You know, when we think of galaxies merging, we usually picture total chaos, right? Stars being ripped out into these long tidal tails, a jumbled, violent mess. But that's not what's happening here. The heart galaxies, they represent a much, much quieter phase of interaction. So let's put this into context. Let's compare the heart galaxies to a more famous merger, the antennae galaxies. Okay, so the heart galaxies are in their very first encounter, so they look way less disturbed. They are just now forming the seeds of a future starburst. The antennae, on the other hand, they're deep into a violent merger. They look chaotic, and they are already having a massive starburst right now. And you can just see the difference so clearly right here. On the left, you've got the gentle overlap of the heart galaxies, and on the right, the chaotic, tangled mess of the antennae. It's a tale of two collisions, showing us both the quiet beginning and the dramatic, fiery result that comes much, much later. And this brings us right to the scientific verdict from the researchers themselves. They concluded that, yeah, this pair is at a very early stage, and what's happened so far is a very quiet collision. So it's not a gentle embrace, but it's not a violent smash-up yet either. It's something brand new, right in between. So why does catching this quiet collision matter so much? What does it really teach us about the big picture, how the universe actually works? Well, it helps us map out the entire life cycle of one of these huge starburst events. It all starts with gravity pulling galaxies together. Then comes the compression, step 2, as their gas clouds smash into each other. This collision forms those giant fuel filaments, and finally, all that fuel ignites in a massive frenzy of new stars. And that's what makes the heart galaxies so priceless to science. They give us this perfect, pristine laboratory to watch steps 2 and 3 happen in real time. We are literally witnessing the gas getting squeezed and the star fuel filaments getting built, all before the main fireworks show even begins. It's a rare chance to see the setup, not just the chaotic payoff. And so we're left to watch this magnificent, slow-motion dance from 60 million light-years away. Hundreds of millions of years from now, these two beautiful spirals will merge into one even bigger galaxy, and their quiet first encounter will just be a distant memory. The question is, as this cosmic ballet continues, what other secrets about how stars and galaxies are born will the heart galaxies reveal to us next?